All right, the final section of chapter 6. Let us begin. So out of the book, this is section 6.8. We're going to be graphing linear inequalities, okay? So, oops, I'm on the wrong page here. Hang on a second. So first off, let's just define what a linear inequality is. And that is, let me change my color so it's in here. Hopefully this is, oh, it's not quite big enough, is it? There we go. It is similar to a linear equation, but we use what it uses, an inequality symbol instead of an equation. An equal sign, okay? So we're not using the equal sign, we'll be using inequalities. You should be familiar with that. Sorry, make sure that's right. Okay, so that's that. All right, so solutions to a linear inequality. So solutions will look like all the ordered pairs, all of the ordered pairs that make the inequality statement true. Okay, that means you can plug in your x, y, and you should get a true statement. So let's just look here at this example. Here I have a linear inequality. It's not solved for y, but I want you to do that then. But just for the sake of checking the solution, first we're going to plug in our x and we're plugging our y into this inequality. So I have 2 times 2, because that's my x value here, right? Oops, I'm sorry, I almost wrote a plus sign. Minus 3 times what my y value is, which is 5, right? I just get those numbers from the ordered pair, is less than 15. So what I'm trying to find out, is this true, right? Does the left side, is it less than 15? Let's simplify. 2 times 2 is 4. Negative 3 times 5 is negative 15. I still want to know, is that less than 15? 4 minus 15 is negative 11, and negative 11 is in fact smaller than 15. So yes, this does satisfy the inequality statement. It makes it true. It's true because negative 11 is smaller than 15. Let's take a look at the second example, okay? So we're still going to plug in to this inequality. Here is my x, here is my y. Make sure you take the signs with you. So we have 2 times x, which is negative 1, minus 3 times y, which is negative 7. And is all of that less than 15? 2 times negative 1 is negative 2. Negative 2 times negative 7 is positive 21. Is it less than 15? Negative 2 plus 21 is 19. Is 19 less than 15? I hope you didn't have to think about that too long, because it is not. So no, this is not a solution. This ordered pair, negative 1, negative 7, does not satisfy the inequality. Okay, let us look at another example. Here we have the ordered pair 3, negative 4. 3 is my x value, negative 4 is my y value. I'm plugging it into that inequality. So 2 times my x value, which is 3, minus 3 times my y value, which is negative 4. Is all of that less than 15? 2 times 3 is 6. Negative 3 times negative 4 is positive 12. Is that less than 15? 6 plus 12 is 18. Is that less than 15? I hope you're all saying, heck no, it ain't. So that's a no. That ordered pair, 3, negative 4, does not satisfy the inequality. All right, one more. We have an ordered pair 0, 0. By the way, That's the money order pair to plug in. It's my favorite one because it's so easy to plug in 0, right? So we have 2 times 0 minus 3 times 0. Is that less than 15? I don't know. 2 times 0 is 0. Negative 3 times 0 is 0. 0 minus 0 is 0. See why 0 is the best? I'm telling you. So is 0 less than 15? Why, yes, it is. Yes, 0 is less than 15. Okay, so that's what it means to be a solution to an inequality. It must satisfy both. You must be able to plug in your x and your y and get a true statement. All right, so here's the steps to graph linear inequalities and to show the solutions on a coordinate plane. So step 1, we want to put the inequality in slope-intercept form. Slope-intercept form. Okay, and if you need a little refresher as to what slope-intercept form is, it's y equals mx plus b. It's solving for y, which you have had practice, so you should be good at that. The only thing different here is we have an inequality, so we won't be using the equal sign, but I just put that there as just like a reminder that you want y on the left side and everything else on the right, okay? So another thing you want to make sure you remember is if you multiply or divide by a negative number, you must flip the inequality symbol. So maybe you want to write that down so you have that as a reference. Okay? So once you've done that in step 1, we're ready to go to step 2, and we're ready to graph the line. We will use a dashed line. We're going to use a dashed line, which looks like this. That's my dashed line for symbols that are greater than or less than. So think open circle when you think dashed line. Right? It's the same rule for an open circle. When it doesn't have a line under it, it's going to be an open circle. It's going to be a dashed line. Okay? So think open circle when you see greater than or less than. Now when we will use a solid line. That's just the regular old line. Looks kind of like this. If it is greater than or equal to, or less than or equal to. So you want to think closed circle, solid line, right? Open circle, there's stuff missing, dashy line. Write this down. Keep this as a notes for yourself. It's going to be useful for your test next week. Okay, so now once we've completed step 1, we solved the inequality for y, and then we are ready to graph the lines. We're going to say, okay, is it dashed or is it solid? We need to be able to answer those questions before we graph. Now here's where the fun part comes in. We get to color on the coordinate plane. So we're going to shade above the line if it's greater than or equal to. Above, right? It's greater than, it's above the line. We're going to shade below the line for less than or equal to, because below, less is underneath, above, greater, above. Okay? Let's look at some examples and maybe this will make a little more sense. If you need to pause this video to copy these notes down, please do so. These are important. You will be able to use your notes on the test, so it's important that you take good notes. Okay, here is an example. First, I'm going to go through the steps. Step 1, I need to solve for y. I need to put this in slope-intercept form. So I'm going to start by subtracting 2x to the other side of the inequality. And I have negative 3y less than, the inequality didn't change, negative 2x plus 15. Remember, I need y to be by itself, but I have this -3 out front. We're not going to add 3 if that's what you're thinking. We're going to divide because this is multiplication between this -3 and y. There's no symbol here. That's multiplication. So how do we undo multiplication? We divide. But we're dividing by a negative. So when we divide by a negative, we need to flip the symbol. So -2. So keep your slope as a fraction. You just always want to reduce it, but you don't want a decimal, okay? So now we have y is greater than 2/3 x, and 15 divided by -3 is -5. That's my inequality. I'm ready to start graphing this. But first, let's look at this inequality. Is it going to be solid or dashy? It's greater than. There's no line under it. So it's going to be a dashed line. It's good to write this down and have this in your mind before you start graphing. Okay? And then it's greater than. Is it going to be above the line or below? Greater is above. So it's dashed above. And you're like, what does that mean, dashed above? Well, watch this. First, we're going to graph the lines like we do with regular linear equations. We start at the y-intercept at -5. So 1, 2, 3, 4, 5. Right there is my y-intercept. My slope is 2/3. It's positive, so we go up 2/3. Now comes time for my dashy line. My dashy line. Try your best. See, when you draw dashy lines, you can't even tell that I didn't draw that line straight at all because it's dashy, so it actually looks pretty good. You don't want it to be solid. I would recommend only using pencil to do this because if you draw a solid line, you can just erase out little spots so that it looks dashed, okay? So now we need to shade above. That means that all of these values above this line, all of these ordered pairs are solutions. Okay, that's how I shade. I use like striping. Some people just scribble, or some people shade it in completely. I'm all about saving time. But this is clearly where all the solutions are on this coordinate plane. All right, let's take a look at 4 more examples, and then I will let you practice on the next 4, okay? So first, this equation, y is greater than 1/3 x minus 5, is already in slope-intercept form, so that's good. So now we can look at the information at the inequality and determine if it's dashed or solid, and determine if we shade above or below. So since it's just greater than, it's going to be a dashed line. And then it's greater, and that means above. So it's dashed and above. Right? We always graph a line starting with the y-intercept, which is -5. So 1, 2, 3, 4, 5 right here. And then the slope is 1/3. So we go up 1 from that y-intercept over 3. 1, 2, 3, make another point. Okay? It's a dashy line. And I'm going to do my best to. I do like it when you guys draw your lines, whether they're dashed or solid, all the way across the coordinate plane, and don't just connect these 2 dots. You need to cover the coordinate plane. Okay, now we're ready to shade above. So that's all of those points above that line. And remember, when it's dashed, that means any point on this line would not be a solution to this inequality because it's not equal to on that line. Right? So that's what that solution looks like. All right, number 2, very similar. It's already in slope-intercept form. I look at this inequality symbol and ask myself, is it dashed or solid? It has a line under it. So this one's going to be solid. Am I going to shade above or below? Well, it's less than. So we're going to shade below. Now let's take a look here and graph this line. First, we always start with the y-intercept, which is -1. Go down to -1 right here. Boom, on the y-axis. My slope is -2. So I go down 2, 1, 2, and right 1. And it's a solid line. So here I'm going to try my best to make a straight line. Again, you want to cover the coordinate plane, top to bottom, left to right, whatever it takes. Make your line longer. And we're going to shade below the line. So this line's pretty steep. So you might be thinking, well, what's below the line? Is it the left side or the right side? We're going to be underneath the line, so we're going to be on this side. If you're not sure, you can always pick an ordered pair from that side and plug it in, or pick an ordered pair from the other side and plug it in, and determine which one satisfies the inequality. All right, so now these next two are not in slope-intercept form, so I need to convert them. Oh, my pen. Right here. Hold on, guys. Okay, we got it. All right, so first I'm going to subtract 5x. And I have -2y is greater than -5x plus 12. Right, we need to get y by itself, so I need to divide, but the problem here is I'm dividing by a negative. Remember to flip that inequality symbol. For some reason I can't draw a 2. Okay, so then I have y is less than, right, don't forget to flip the symbol, 5/2x minus 6, because that's 12 divided by -2. Here's my inequality. Now it's going to be dashed, because it's just less than, and it's going to be below, because it's less than. Okay, we start at -6 on the y-axis, so 1, 2, 3, 4, 5, 6 here, boom. Slope is 5/2, so we go up 5. 1, 2, 3, 4, 5, and over 2. Make another point. It's a dashy line. Be careful and conscious about that. Okay, there's my dashy line. It covered the coordinate plane. I'm shading below the line, underneath the line. There's all my solutions. Okay, one more to go. So now I have this inequality. I need to solve for y, so we're going to subtract x first. And I get -4y is less than -x plus 8. Divide by -4. And remember, we're dividing by a negative, so we have to flip the symbol. Now it's going the other way. Y is greater than. Remember, there's an imaginary 1 here, so if you want to just write it as 1/4 x, that would be fine. You could leave the x in the numerator, but this is okay too. And then we have 8 divided by -4, which is -2. All right. Now I'm like, dashed or solid? Well, it's dashed because it's just greater than, and it's above because it's greater than. All right, when we go to graph this lovely little gem, we start at -2 on the y-axis, which is right here, and then the slope is 1/4, so up 1/4. 1, 2, 3, 4, right there. Now remember, it's a dashy line. Oh, this one's kind of really steep. Well, flat, I should say. Flat line. Right? I covered the coordinate plane. We're shading above. That's everything up here above the line. Okay? Hopefully that wasn't terribly difficult. So what I'm going to do is I'm going to give you 4 more problems here. I want you to try your best for 5 and 6. 7 and 8 are a little strange, but I will go over them. So pause the video and solve 5 and 6. Make sure you solve it for y. State whether it's going to be a solid line or a dashy line, and if you're going to shade above or below. Okay, so hopefully you solved 5 and 6 and you got the same thing that I got. Y is less than or equal to x minus 8, which means that it is a solid line and you shade below because it's less than. But look, I didn't shade below, I shaded above. I made a mistake. Oh my goodness, and I even wrote below. What a silly goose. Okay, that's another reason why it's really good to use pencil. All right, so we need to shade below. Solid line and below. Then for number 6, y is less than negative 3/2 x plus 0. Start at 0, up 3, right 2, make a point. This is a dashed line because it's not equal to, and it's less than, so we shade below. Okay. All right, so 7 and 8 are a little different. I'm hoping you're looking at 7 and you're thinking, oh, it's a y line, so it's a horizontal line. We need to know, there's nothing here to solve first off. We need to know, is it solid or dashy? Well, it's solid because it has a line under it. And are we going to shade above or below the line? Well, it's less than, so we're going to shade below. So let's graph this line. Y is less than or equal to negative 4. So we start at negative 4 on the y-axis. 1, 2, 3, 4. Make a point. It's a horizontal line. So we're just going to go straight across because it's solid. And it says it's less than, so we shade below. Okay, cool. Now number 8. There's nothing to solve. There's only one variable. X is greater than 7. Well, greater than, without a line under it, it's going to be dashed. So it's going to be a dashed line. And are we going to shade below or above? Well, it says it's greater than, so we're going to shade above. So let's graph this line. First, we're going to go to where x equals 7 and make a point. And this is a vertical line. So 1, 2, 3, 4, 5, 6, 7. And we're going to do a vertical dashy line here. Like that. Okay. Uh-oh. How can I shade above this line when it's a vertical line? So I'm going to put a question mark because, like, now what do I do? Well, I want you to think about the number line, right? X is just a number line. The x-axis is a number line. We want all the values that are greater than 7. So is greater than 7 going to be on the left side or on the right side? It's going to be on the right side. All of my greater values are going to be on the right. So make sure that your shading makes sense to the inequality statement. All right, and if you have any questions, be sure to message me and let me know. I'll be glad to help you. Have an awesome day. And you better have written everything down because you know you're allowed to have notes on this next test. So I will come at your life if you do not have your notes on test day. All right, bye.